Thanks everyone for joining. As Leslie mentioned, we have a lot of fun with these product roadmap webinars, both as a chance to share what we're working on that we're excited by, but also to hear from you all to keep us calibrated on features that you're excited about, feedback that you all have on the platform. And so, as Leslie mentioned, we'll go through two parts today. One, a look back on some of the features that have come out in the past quarter, just to make sure that everybody's up to speed on that. And then we'll be taking a look at what's coming out on the quarter after that. And as Leslie mentioned, I'm also joined by Shawn, who's going to take us through some of the live product demos as well. Hey, Shawn.
Hey, folks. Hey, Sheel. Let's do it.
Let's do it. So with that, we'll get started. And the first part is we will do a quick look back on some of the spotlight or highlighted features that we want to make sure that folks are familiar with that they do have available in the Ascend platform. The first one is, well, a personal favorite, but clearly a fan favorite across Ascend, which Shawn, correct me if I'm wrong here, but is, I think, the fastest feature we've seen adopted in the entire Ascend platform in the history. Yes?
Yeah, totally.
Okay, cool. I think it was 100% adoption within 2 days of the feature is I think what it was. And that first feature is, oh, let's see if Google Slides helps us out here. Component pausing. And so this is where developers inside of Ascend can control whether a component is running or paused. So as you all are familiar with the Ascend platform, components are constantly checking, is there work to be done, what work needs to be done, do the incremental management, and everything that you know about getting that component up to date. However, we have heard feedback and folks would like to have the ability to temporarily say, hey, this component I want to pause. Maybe I'm building out some components after that component, and I don't want to have everything running as I'm just sort of sorting out a couple things, or maybe something that was built is not working quite as we thought, and so we want to go ahead and pause that. And so this feature allows you to do that. Not only can this be helpful while you're developing and being able to isolate change that you're making there, but it will also terminate processing for anything in flight. So if a component is currently running and maybe there's 10 partitions that are running, so 10 in-flight Spark jobs, those would all be killed when we pause the component. And then when you resume the component, they would start over and catch up. And just like Ascend, everything will catch up and become up to date. So with that, I could keep explaining it, but better would be if Shawn kind of just shows you a quick snippet of the feature. So I'll turn it over to Shawn to give you all a sense of what that looks like.
Yeah, sounds good. So we have our little pipeline here that is running happily. Now, let's say we want to make changes on a portion of the pipeline, which includes these transforms. What's going to happen if without the component pausing feature is once a change is made to one of these components, it will start running and processing. But in our case, we do know that the logic is going to change for all three of them. So we don't want the components to process immediately once we make a change to individual one. So what we can do here is really find the first component that we want to process, and then hit and do a right click, and then do a pause. And that is going to halt any processing for this component as well as all the downstream components. So this component will be paused as well. And then we can make changes on this one and the subsequent one. Once we're done, we can then unpause it again using the right click, and the processing would resume for all these components, which make it very nice when you're working on a lot of components at the same time. All right, back to you, Sheel.
All right, let's head back over to the slide deck here. So next feature up that we did want to talk about is the schema viewer. So in Ascend, when you're developing your components, you're typically developing that on the query panel, which allows for faster iteration and development of trying how those components work as you're developing them. One of the things that we noticed, though, was that as folks were developing components in that query panel, we found that you ended up having a multiple tab experience where you would have some more ascend tabs open so that you could look at the graph, look at the schemas of your components, and do some flip-flopping there. So what we have introduced here in the query tab is a schema viewer on the left side of the screen, which allows you to look at the queries, the schemas right there when you're writing the query and make it faster to develop. The other thing that is introduced with this schema viewer is that the UI is now more semantic. So on the left side between the build panel, query panel, and govern, you can now stay in those modes. So when you click build, you get immediately back to the build panel with the graph. When you click query, you're immediately in a query mode. And so overall, refining this UI and this experience for developers in Ascend and making things easier to work with. We're going to take a look at this one with one other feature at the same time here, which is SparkSQL. So for those of you who maybe noticed when Shawn shared his screen that other time, is you may have noticed a certain number of components that are SparkSQL. This is available now in early access. So if your account does not have it enabled, please reach out to your Ascend account representative and they'd be happy to get it enabled in your account. But what do you really get with a Spark SQL component? Well, historically, the Ascend SQL transformations were a subset of Spark SQL. They allowed you to use the same syntax of Spark SQL, but they did not allow you to do full common table expressions or subqueries, and they had certain limitations compared to the full dialect of Spark SQL. And so with introducing this transform type, it is our fourth transform type coupled with Python, Scala, Java. This allows you to implement everything that you'd like to do in that SQL component. The syntax here is shown on the right. So you're seeing an example here of a common table expression and being able to then use that as part of your select query. And the main difference that you'll notice compared to Ascend's previous version of SQL is to make things more explicit when you're referencing a different component's ID is you will surround it in double curly braces. So that's what we're seeing here is we're being more explicit of we're pulling from the component ID called opportunities. The second change that we're introducing with Spark SQL that we're also super excited by, and this comes from all of your great customer feedback, is historically in SQL components for partition handling, it was inferred from the SQL statement. So from your SQL transform, Ascend would attempt to figure out whether it should be a mapping or a full reduction or a repartitioning. What we found from customer feedback, though, is that in that, for example, a repartitioning component, the developer would already know what kind of partition handling they're trying to do, that they're trying to do a repartitioning. And then instead was trying to figure out the exact SQL syntax in order to get Ascend to realize that it's a repartitioning component. So in this revamp here and in this Spark SQL, we are instead making it configuration based, just like our PySpark and our Scala and Java components. So not only does this bring more symmetry across all of our different component types, but also brings in explicitness so that the developer can more simply just say, in this Spark SQL transform component, I am doing a repartitioning based on this column. So for a quick look at both of those, we're going to hand it back over to Shawn, who's going to show us both of those in action.
Yep. Right. Yeah, it's me again. So we have introduced the, as you mentioned, the fourth type of transform, SparkSQL, and you can really easily create them. They're kind of similar to the legacy SQL one. The only difference is we're using different syntax to reference tables. So notice the double curly brackets, and we put table in it to tell Ascend, oh, this is actually a table or a input. And as you mentioned, we can also explicitly specify how to handle partitions, like in PySpark and Scala, using this dropdown. One thing super cool is we have also enabled Spark SQL for queries. A lot of folks are using queries to do debugging, prototyping. So let's take a look at this one. This is our query view. And as Sheel mentioned, we have released a schema viewer on the left and put the history of queries to another tab. So for the schema viewer, this is really a list of all the tables or all the reconnectors, transforms, and data feeds that are available in this data flow. Let's say that we want to run this query, and see the results. So this query, as you can see, is again a SparkSQL query with double curly brackets. Something super cool about the schema viewer is we have these little helpers on the left panel. If you click it, it really helps you do a quick profiling of the column. And again, you can do a quick profile of the table as well. And if you run it, it would give you the results kind of immediately right away, which is something I personally really like. Cool. I think that's a quick intro on both SparkSQL and the schema viewer. All right, back to you, Sheel.
Awesome, thanks, Shawn. And before we switch back, one of the features that didn't make the highlight reel of today, if you will, but I think is super exciting, is the backend for all of this on the query has actually been switched out to be, as I understand, 50 to 100% more performant in terms of speed, and can even now, depending on your environment configuration, auto scale. Yeah. All right. Which I think, didn't maybe make the highlight reel in terms of the slides, but I think worth calling out, especially for folks who maybe are using the query to help debug bigger data sets. Now, instead of having to wait longer or maybe trying to do any workarounds of sending that data to a warehouse, you can now more easily just quickly query that data in Ascend and get those scale benefits.
Yep.
So,
it's really
all
good.
right. So let's switch back to the official highlight reel then. And next up on the docket is partition logs. And really what these are, and we've branded this as partition logs because, as you know, Ascend has a lot of partitions. Really everything in big data has a lot of partitions, but this allows you to get to the Spark logs for every single partition for every component. This makes it faster to iterate and debug what's going on, or have more self-service debug if you're seeing an error of, maybe lost Spark workers because they've crashed and you want to get more insight as to what's going on in that log or how far it got. The partition logs is a great way to be able to see the full underlying of what's going on in that job. And one of the other things that you can do in the partition logs is instrument some of your own logging functionality as well. And we're going to check out one more feature, and then we're going to hand it back over to Shawn to show us two features again. But this one is the super customizable, we want to let folks do the things that they need to do in Ascend type feature, which is custom Docker runtimes. Historically, Ascend has always deployed on Docker containers. And for the first time now, we have made those Docker containers available. So the official Ascend Docker containers can be found on Quay, and this can be really useful to develop locally. Maybe if you want to develop PySpark transforms locally and send it through the official Ascend Docker image, as well as then customize that image, add in your own custom libraries, build in your own code, customize it as you need, and then push it back to Ascend and have Ascend use your customized version of the Docker container to run on. One of the other features that this will enable for us is in building your own connection types. So your own read connections, your own write connections, things like this, having them be able to be on this extended Docker runtime, push that back up to Ascend and have those custom connection types be available in your own environment, sitting side by side as native connection types. So that's a feature that's going to be enabled by these Docker runtimes that we don't have out yet, but is supported by this Docker runtime feature. So Shawn's going to give us a quick overview of both of those features, just to give people some insight there.
Yeah, sounds good. So as you mentioned, custom Docker is something that can really make writing PySpark transforms and Scala transforms easy and more flexible. Let's take a look at this one, for example. Here, we're trying to import a Python package called Arrow, which we all know is popular to deal with timestamps. Now, this is actually not a package that is natively available in the Ascend Docker image. So as you can imagine, it would fail complaining that the Arrow package is not available. We don't have that module. Now, what I would do in this case to support this use case is we can really build a new image out of based on the ascent image. And this is something you can do in like 2-3 minutes. We do have some really good documentation around this. Once done, and in this example, I just push my new image to Quay again. I can then reference this image from my transform. So this transform is almost using the same code, importing the arrow package, and it does finish. You can see that this would run as expected. Now, if somehow your transform is having issues that you're trying to do some debugging on it, one thing super cool is you can import a logger function from Ascend and writing out your own logs. For example, if you want to document some results, intermediate results, the logger would work. So how we're going to access the logs is via partitions, and there is a view log, or you can also download the logs, which is going to stream all the logs to you. So this is a log file. This is all the logs for this existing partition. If we take a look at the exact line that we try to log, so let's try search for here. We can see the log line up here. And this is really helpful for quick debugging and prototyping purposes. Cool. I think that is custom Docker and partition logs. Back to you, Sheel, again.
Awesome. Yeah, and I think as we go forward here on what's coming up in next quarter, where remember these logs because we're going to come back to them. But first, there's a couple more features that went out that we would want to highlight to everybody. And so that is the Ascend single Kubernetes clusters, sort of an internal name that we've been using, which single Kates is how we've always referred to it internally. But historically, Ascend has deployed in 2 separate Kubernetes clusters. And we've used that to push services on one side, push Spark on another side, things like this. However, as Kubernetes has progressed, the features have increased, and we've reevaluated what we can do with certain things, and we've had our own internal features change around it as well. We've now been able to scale down your Ascend deployment to a single Kubernetes cluster. So depending on your cloud provider, this is about a 20 to 30% cost reduction, and this is live in all environments, so you should be seeing that already. But not only does it help decrease that baseline footprint of Ascend, it also does increase the overall efficiency, because now instead of only being able to bin pack on 2 different clusters and having some leftover space, we're now bin packing and deploying all of these pods and services on one single cluster. So you should be seeing as well better efficiency, better scaling parameters, and benefits from that as well. The third thing I will highlight, and this is a little bit internal to our own Ascend feature delivery velocity, but it will allow us to deliver primarily features that historically required cross-cluster networking more quickly, because now we can deliver those features without having to figure out all that networking and across those clusters and things like this. But I will say, and for folks who are like, what about the security of it? We are highlighting to folks that we are maintaining those hardened security boundaries, that user developed code and Spark code that you're writing still does not have the access to the services, the internal Ascend services, and anything that you would be worried about as we do this consolidation. So you should be seeing all benefits, no downside. We're really excited to have pushed this change out. I believe it went out about a month, maybe a month and a half ago. Maybe Shawn, you remember more precisely than me. Is that about right?
Yeah, that's about right. Yep.
Awesome. Now, before we end this highlight reel, one of the things that I want to call out to folks as well is that, and hopefully you're feeling this way as well as a lot of, I know, Ascend customers are listening in, is we do dedicate an enormous amount of our backlog and prioritization to features to help unblock customers, staying responsive to what people need. And so did want to do a quick just highlighting of some of those features. And Leslie's thrown up a poll for us here as well. And as we're talking about these features, feel free to participate in that poll around some of the features that you were most excited about to see that came out of Ascend. But the other features that I did want to highlight is us staying super responsive. So continuing to build more read connections and ingesting data from more sources. making clusters scale more efficiently in Azure and AWS, supporting faster launch times on VMs and AKS so in Azure, and handling things like that. So as we get into next quarter's roadmap, I do want this to serve as a reminder of please keep giving us feedback, stay responsive with us because we'd like to stay responsive as well. And we want to keep building out the features that folks are really excited about.
Fun
So
fact on the poll real quick, I'll say it's pretty evenly split so far. I've only hit it up for about a minute, but right now it's pretty evenly split amongst what people are excited about, which makes us happy as well. So
that does make us happy. When we were discussing internally, I think maybe just yesterday or day before, we thought we might see a huge skew towards maybe particularly SparkSQL or component pausing, which I know are some fan favorites internally as well. But really cool to see the appreciation as well for Docker runtime, schema viewer, and things like this. All right. Now, for the part that I'm sure everybody is really, really excited about, what's coming up next for Ascend? How can we make this platform even better for everybody on it? First things first is a bit of a project that we've been carrying over from the previous quarter that we're going to be rolling out fairly soon here at the beginning of this quarter for us, which is the custom write connectors. And these custom write connectors are a way for us to build a new Flex foundation behind our write connectors, similar to what we did previous quarter on the read connectors when we did the Flex read connectors. This was doing the Flex write connectors. And with that brand new foundation for this, we want to be able to more quickly iterate and support the myriad of places that people are trying to get data to. If this sounds like a repeat from last quarter, it's like, yes, last quarter we did this effort to be able to more quickly support all the places that people wanted data from. So now let's do that other side of where that data goes to. And Leslie's thrown up a poll for us here of, which write connectors would you be super excited to be seeing and have that enabled? So I've got some specific examples here on the slides of some manifest file formats that we want to get more formats approved, not approved, but in the platform to better participate in like things like Athena and other services like that. Revamping how we're doing the writes to warehouses so that we have more configuration parameters in there and can support more different styles. Expanding those lists of databases. We support many of these today, but we know that a lot of times when you're working with big data, after you've gotten it aggregated or ready to be served, you might want to throw it into something like a Postgres so that you can serve your web traffic from it and get that low latency but highly aggregated data served off of that, as well as getting those into Delta Lake, sending them off as webhooks, writing them into queues, Kinesis streams. So please do take the poll. As you all know, we prioritize connectors and which ones we're building based on the feedback we're getting from folks. So this really helps us understand that. And one other thing that I'll mention is similar to read connectors, once we start opening up the foundation for you all to build your own, that would be on the read connectors and on the write connectors so that you all can build your own use cases, whether it's loading that data straight up back to your own APIs, let's say, or maybe some other system or data store that we don't yet natively support. Shawn, any on your, if you were to take the poll, which one are you super excited about?
I think I'll definitely I would definitely vote for Delta as well, and I see one vote for custom webhook, and that is actually something that I'm personally really interested in. I just feel like there's a lot of use cases that we can enable if we can write to just custom webhook locations as well.
Yeah, makes total sense. So we're super excited to start delivering these all for you. As you all know, this is a quarter roadmap look ahead here for the next 3 months of Ascent. And I will mention that write connectors, since we got started on it last quarter, should be coming in pretty soon here at the beginning of this quarter for us in Ascent, which also similarly, for those of you who have been paying attention from the last quarter, are the extended data types. So the first set of extended data types did go live last quarter, such as byte and decimal. And so you do have those abilities now in the Ascend platform. And what we'll be working on next is these additional array, map, and struct types. And so at this point, between the new SparkSQL transform that you saw previous and the full data types, you will have the full abilities end to end of everything in the Ascend platform. So we're really excited about that. And similar, as I mentioned, with write connectors, this one should be coming out fairly soon here early in our quarter. as well. Next up is the Spark UI. And so we've had quite a few requests for this over the time, where even though now we have partition logs, even though Ascend is surfacing a lot of data of the different partitions and how jobs are running, sometimes you just want that full Spark UI to just see what's going on, understand if there's something wrong with the query plan that maybe you want to adjust in your code, understand what it's up to, or sometimes you're just waiting for it to finish and it's nice to look at something too. I get that, I've been there. And so what we will be doing is enabling the Spark UI and making that available in the partitions tab as well inside of Ascend for basically more visibility into your running Spark jobs. Pretty excited about this one. I know a lot of customers are excited. Shawn, anything to add on this one?
Yeah, I feel like this is something we can really bake into the product so that instead of having to go somewhere else to look, we hopefully can bring it inside the product. And it should be fairly straightforward to use.
Yeah, awesome. Yeah, I think the more things that are seamless, then the more compelling a platform becomes. So definitely excited to get that one integrated.
Mhm.
Next one up, and for those of you who said, remember logging, we're coming back to it. Here it is, we're coming back to it. So for the logging systems, now that we're collecting all of these logs, surfacing them, making it easier to work with a lot of these logs, the next feedback point that we've gotten from customers is, now I want all those logs in my logging system that I'm familiar with so that I don't have to learn new query syntax, so that everything's there just alongside everything else. And so we will be providing ways to integrate those Spark logs to your own customer logging platforms. Some of the ones that we're thinking about and highlighting are Splunk, Logic, and Datadog as some of the top ones. If you all have other ones that you're like, oh my gosh, this sounds great, but I wish you could support blank, throw them in the chat. We'd love to get that feedback as well. But the idea here is keep folks in tools that they're really familiar with, even though we want to keep continuing to offer like a unified platform for data engineering. We understand that with something like logs, it makes a lot of sense to be able to use it in tools like that. All right, next one up here is, this one's a little bit in the weeds, so I'm going to give folks a little bit of background context, but in Ascend, everything does retry that is retryable on an exponential backoff schedule. And we've tuned those parameters over time to work with best case, or not best case, sorry, work with most common failure scenarios that we see in the platform. So for most things, you'll see a retry schedule of immediate, after a minute, after 5 minutes, and then after 10 minutes. And the reason why is because immediate is maybe something just blipped out or just flaked. Just one retry is just going to fix it up. So let's just get that done immediately. As we get to the order of magnitude of 1 minute, it might be something with pod failure and Kubernetes, maybe a little bit longer of a networking split, things like this. So let's try again after 1 minute, after things have a chance to settle down. 5 minutes and 10 minutes as we start getting to instance failures of bad instances that need to get rotated out, things like this. So for 80, 90% of use cases we've seen across customers, we've tuned this to handle for best fit. However, just because that's our context doesn't mean that that's going to be the exact right errors and retries for all components and in all use cases. And so we're excited to be opening up the ability to customize errors and retries so that you can best fit it to the use case and the domain and the business context that you have around what's going on in that use case. All in the vein of what you know about Ascend is, how do we make things more automated, more autonomous, less operator intervention? And this is something that fits straight into one of our key mentalities that we're looking to have solved with Ascend. So really excited to get this one out. Shawn, I'm sure you've worked with customers who are just like, yeah, if only we had one more retry here because that API was flaky or things like that.
I think the word our customer used was hopefully hope the platform can be more forgiving. I think that's a really good word here.
Yeah.
So yes, and we can actually customize that behavior, which is super awesome.
I think so. Yeah. Cool. All right. Now, this one, I'm going to spend a little bit more time on it because we are super excited for this feature. It is really going to change the game for Ascend, and this is our grand finale, but it takes a little while to understand what's going on and why this one's so compelling. So as you all know, we make a lot of SHAs in Ascend. We SHA code, we SHA the input data, we SHA how things are coming out of the system. We're SHAing artifacts and fragments. We create a lot of SHAs. this is the introduction of a new SHA. In case you were like, there's not enough SHAs, we're missing one. Yes, we are adding a data SHA. And what this is going to allow us to do is take each partition of data and create a SHA that best represents what is in that data set. You might then be thinking, okay, so then what? And this is where we're going to take a step back into a little bit of how Ascend works. So as Ascend is computing each component's artifacts, every a component is generating an artifact SHA, which tells us, does the artifact exist already or does it not? And Ascend is this constant fixing system, which is constantly looking at all of the artifact SHAs, constantly looking at what we actually have and determining, does work need to be done? And I'm going to give you all a simplified formula to help understand how we compute that SHA. Is essentially it's the input component artifact SHAs plus the code SHA essentially gives you a sense of what that output artifact SHA is going to be. That is vastly simplified. There's much more going on, and I'm butchering some of the different SHAs here, but for reduced complexity here, that's essentially how it works, which means that if your code changes, then all of your artifact SHAs are delta'd now, which means that everything's going to rerun. And since all of that reruns, everything downstream of that is going to rerun and so on and so forth, because the formula has changed in terms of input plus code gives you the output. And that has sort of papered over one optimization that optimization almost makes it sound smaller than it is. One truth here, where it is possible to do different code and get to the same data. And the data SHAs will now allow us to acknowledge that possibility in that the code could have been changed, but the output data is the same. And using that data SHA allows us to then stop downstream propagation. So certain use cases here that I'm super excited about is historically, if you've had a code change, you could use manual fingerprinting in Ascend, in which case you would control whether the code has changed and whether anything downstream needs to change or not. Or you would use the automated one, in which case everything would propagate. Now you can let Ascend process that component over again, see what that output data is, and if you have truly generated the same artifact, will stop propagating. Now here's the part that gets super cool about this as well, is it will work per partition. So you can go ahead and make your code change that's maybe handling some newer data format that's come in. It'll go ahead and reprocess, make sure that none of your historical data has actually changed because of that business logic, and those historical partitions would hit the data SHA, not propagate, and those newer partitions would use that new code logic, and those would go ahead and go on and propagate. And so we think this is a really big game changer at Ascend. You will have reduced sensitivity to change management. You will get that feeling of let's constantly just keep updating our business logic. Again, having that confidence that the right stuff is processing, that your data integrity is always in check, and you have that confidence of what is going on with your data set and why.
So for this one, Sheel, when I first saw this, I was also a bit curious. I'm pretty sure some of our audiences might share the same questions. Like, wouldn't it be very costly to compute the SHA from the data?
Yeah, good point, good question. So we've spent quite a bit of time internally on what our SHAing algorithms can look like, how we can create this, because yes, you're correct. While a lot of what Ascend is doing operates on the metadata of the data, this is going to operate on the data similar to your customer actual transform jobs. And we have found that we can generate a SHA more efficiently than other jobs needing to run. So to put that in perspective, we've found that yes, although we're going to be paying a little bit more computational effort as part of those transforms to generate this data SHA, if we can even save one partition downstream, one Spark job, we're winning overall. So we've tuned this. We're pretty excited about that. But yeah, we're the wins here are going to outweigh the little bit ones. Yeah, but that's a great call out as well, because certainly we can see that from folks of like, yeah, well, how is that going to work?
Yeah. Cool.
So with that, I will take us to questions. If anybody's curious about certain things or anything that we can help provide more clarity on, please let us know. Again, thank you all for joining. For those of you who are dropping off, thank you all for joining. We hope to see you again for another product roadmap one in another couple months. And of course, we're really excited to deliver these features out and to get it all into your environments.
Yeah, so we have a couple of quick questions that have come in. So still have a little bit of time, so please go ahead and throw your questions in as well. If you have any, we can certainly get to those or answer them via email after the fact if we need to. But one on Flex write connectors, which is just like with the read connectors, will you still be able to use your legacy write connectors once the new ones are on board, or will everybody need to transition over?
Oh yeah, fantastic question. Thank you. So as you all know, we're going to give plenty of notice upfront if and when we do remove any features. So just like read connectors, you will still have the legacy write connectors available. You will still be able to create them, use them. There will also be the new ones available. And we're going to encourage the same pattern as we encouraged with the read connectors, which is for new use cases, please do try to use the new ones since they're awesome and they're better and they're easier to use. But there's nothing that if for some reason it's not working right and you need to discuss with us, or you need to fall back real quick, or you're like, oh, okay, cool, I can do that for the new use cases, but I don't want to migrate everything old right now, there's going to be no pressure to do that at this time. Now, one of the things that I will mention is, for those of you who have been paying attention from 2021, is we've done new read connections. We have introduced a new SparkSQL over SQL, and we're going to have new write connections over the legacy write connectors. So really, when you think about an ETL, in the course of this year alone, we'll actually have been replacing those core components with these new ones that we're super excited about. And one of the big things that we're going to be helping customers with is, after data SHAs is released, we're going to be using data SHAs as a mechanism to help us leverage the data SHAs to help folks convert over from some of those legacy components to the new ones. And because the data SHAs will be in place, as we convert components over, we'll actually see very little processing that needs to happen in that conversion, as we can leverage those data SHAs and keep those things symmetric. So more details to come after data SHAs are out there, and we will be working with customers on migration strategies and working more individually with everybody as to what we should replace when and why. But yeah, there's really no immediate pressure to do any cutover as soon as we release them.
Okay. One other question on the write connectors, people seem to love their connectors, is there an option for ones that they didn't see on the list? Which I think I can answer this, so I'll give it a shot, and then Sheel and Shawn can correct me, which is, sure. Yes, absolutely. Talk with your particular support person, whether it's Sheel, Shawn, Tom, whoever, or jump into the community Slack. I'll plug this here. Jump into the community Slack. We have a feature request channel in there. You can always request new connectors, and we can certainly, take a look at those.
Yeah, and we're super excited to be opening up more customizability there as well, since we know there's just a lot of use cases out there. And because folks are getting so much value of how the Ascends graphs work, how your data integrity works, you just want it in that last piece as well. So we're definitely excited to both have more natively built in the platform and start opening up the ability for you all to develop your own, customize, etc.
And it's actually, I just want to add, it's actually a lot of fun to write
Shawn, have you been working on some of these recently? Is that what's going on? Yeah.
Like the Google Ads one, to them we'll be looking at a different new vendor, Live Asian, like all these different APIs. Trying to hook them up, and reading from or writing to in a sense. That it's actually quite funny, and it's not that hard at all. So yeah.
And I think that's definitely to speak to the frameworks and the interfaces that we try to open up inside of Ascend. We do try to minimize things to your business logic, just the parts that you need to customize, and make that very fast to do that. And if that doesn't sound fun, no worries, because we're going to always continue to keep adding more native ones to the platform. So yeah.
Fantastic. Well, everybody, thank you so much for joining. Thank you, Sheel and Shawn, for putting on another great conversation. Please feel free to reach out if you have any questions. We will also Oh, hold on. We got one more
One more.
question before we let everybody go. It just came in. Does data SHAs differ with existing incremental updates in Ascend?
Yeah, so I like to think of it as an expansion of incremental updates. So historically, as we've computed the incremental update, that new input partition goes through that code and then becomes an output partition, so on and so forth. Data SHAs would allow us to change out code behavior or some of those partitions if we see the same result. So for example, let's say there were 3 input partitions to a component, and it was generated an output data set as a full reduction, for example. And then we do some stuff with that output data set downstream. In this data SHAs and how it works historically, if a 4th partition would show up, it would be processed through that full reduction, let's say, and we're creating one output data set. Even if that output data set was the same, because that 4th partition was disregarded in your actual code logic, Ascend would propagate that through, because at the metadata layer, we saw that there was 4 input partitions. It generated a new output artifact SHA because of 4 input ones. So there's no certainty that we could have reused it. The data SHA would give us that certainty that that 4th partition was irrelevant. The data set is the same, and everything downstream does not need to compute.
All right, sounds good to me. Any last questions before we wrap up today? All right, I think we're good. Again, if you have any questions, feel free to reach out to us, jump in the community Slack. We will be sending this recording around likely tomorrow, so everybody can take a look at it again at their leisure. And again, we really appreciate everybody joining. We hope you enjoyed hearing us chat about what we've been up to and what we have coming up, as much as I know Sheel and Shawn have appreciated chatting about it. So thanks so much.
Thank you for attending.
Yeah, thanks, everyone. Bye.